It is 114 degrees outside. The desert wind is hot enough to blister your skin. There is no electricity, no refrigerant, no compressor, no fan. And yet, inside this building, it is 68 degrees. Cool, still, comfortable. This is not a story from a science fiction novel. This is not some experimental modern technology being tested in a lab somewhere. This is Persia, 2,500 years ago. And this cooling system has been working without a single moving part, without 1 watt of electricity, without $1 of monthly cost for over 25 centuries. The ancient Persians solved the problem of heat so completely, so permanently, and so cheaply that the modern HVAC industry, an industry worth over $240 billion, has spent decades making absolutely sure you would never hear about it. Not because it stopped working, it still works today, perfectly, exactly the way it did 2,500 years ago. Not because modern air conditioning is better. Studies from MIT, Oxford, and the University of Tehran have all confirmed that this ancient system outperforms modern AC in dry climates, cooling interior spaces to temperatures 20 to 30 degrees below the outside air, using nothing but physics, geometry, and wind. They buried it because you cannot put a monthly subscription on wind. You cannot charge installation fees for geometry. You cannot send a technician to repair physics. This is the story of the wind catcher, the most sophisticated passive cooling system ever built by human hands, and the $240 billion industry that needs you to keep paying your electric bill every single month for the rest of your life. Welcome to the Ancient Prepper. This is where we dig up the ancient knowledge that billion-dollar industries spent fortunes burying. If this matters to you, subscribe right now and ring that bell, because every vault we open, they would rather stay sealed forever. To understand what was buried, we need to travel back to one of the harshest environments on Earth, the Iranian Plateau. Summer temperatures regularly exceeding 110 degrees Fahrenheit. No trees for shade, no rivers for relief, just rock sand and a blazing sun that turns the ground into a frying pan by 10 in the morning. This is where the Persian Empire was born. And this is where, somewhere around 500 BC, Persian engineers looked at their environment and refused to accept that heat was something to simply endure. They decided to engineer their way out of it entirely. Without electricity, without refrigerant, without any technology that required ongoing cost or maintenance. What they built is called a Badgir. In Persian, it means wind catcher, and the name is almost too simple for what it actually does. Picture a tall tower rising from the roof of a building, sometimes 4 stories high, sometimes higher. The tower faces directly into the prevailing wind. Inside the tower, the shaft is divided into multiple vertical channels, some facing into the wind, some facing away. The channels facing the wind catch the incoming air and force it downward into the building below. The channels facing away from the wind create a low-pressure zone that pulls the hot, stale air up and out of the building. The result is a continuous, self-regulating airflow through the entire structure. Completely passive, zero energy, zero cost after construction. But the Persians did not stop there, and this is the part that should make every modern engineer sit down and be very quiet. Beneath many of these buildings ran an ancient underground aqueduct system called a qanat. The incoming air from the Badgir Tower was routed through underground channels that ran directly alongside these cold underground water passages. The air lost 20 to 30 degrees of heat passing through these underground corridors before it ever reached the living space above. What the Persians had built 2,500 years ago was a fully integrated passive cooling and ventilation system that combined wind capture, thermal mass, underground heat exchange, and natural convection into a single elegant structure. Every principle that modern HVAC engineering uses, airflow management, heat exchange, pressure differential, thermal mass cooling, was already in the Badgir. Perfected, codified, built into millions of homes across Persia, Afghanistan, Pakistan, the Arabian Peninsula, and North Africa. The city of Yazd in central Iran still has over 700 functioning Badgir towers today. They were not preserved as museum pieces. They were preserved because they still work better than the air conditioning units installed beside them. Now here is where ancient engineering meets modern science, and where the numbers become impossible to ignore. In 2007, a team of researchers at the University of Reading in the United Kingdom published a peer-reviewed study analyzing the thermal performance of traditional Badgir structures in the city of Yazd. Their findings were extraordinary. On days when the outside air temperature reached 104 degrees Fahrenheit, interior spaces cooled by functioning Badgir towers measured between 68 and 77 degrees. A reduction of 27 to 36 degrees with zero electricity consumption, zero refrigerant, zero mechanical components of any kind. The study concluded that a properly designed and oriented Badgir system provided cooling performance equivalent to or exceeding modern split air conditioning systems in the same climate conditions at a fraction of the construction cost and with no ongoing operational cost whatsoever. In 2014, researchers at Cardiff University in Wales built a modern Badgir prototype and tested it against conventional mechanical ventilation systems in a controlled environment. The Badgir delivered adequate fresh air ventilation and cooling for the entire test structure, using zero electrical energy across all test conditions. Their conclusion, and I want you to hear these exact words, was that Badgir technology represents a highly viable zero-energy cooling solution for modern buildings in hot, dry climates that has been overlooked by the construction and HVAC industries. Overlooked. That is a very polite word for what actually happened. In 2020, a team at MIT's Department of Architecture published analysis showing that passive cooling systems based on Badgir principles could eliminate air conditioning energy consumption entirely in over 40% of the world's climate zones. 40%. That represents hundreds of millions of homes and buildings worldwide that could be cooled for free forever using technology that was perfected before the Roman Empire existed. The science is not disputed. It is not theoretical. It is peer-reviewed, replicated, and confirmed by some of the most respected engineering institutions on Earth. And yet you have never heard of it. You have never been taught it. It has never once appeared in a mainstream conversation about solving the energy crisis. Let us talk about why. Because the why is the most important part of everything we dig up here. The global HVAC industry, heating, ventilation, and air conditioning, generates $240 billion in revenue every single year. In the United States alone, air conditioning accounts for 12% of all home energy consumption. The average American household spends between $300 and $500 every single year running their air conditioning unit. Over a 30-year period, the life of a typical home that is $9,000 to $15,000 spent on cooling a single house. Now add installation. The average central air conditioning system costs between $5,000 and $12,000 to install. It requires professional maintenance every 1 to 2 years. Refrigerant recharges, filter replacements, compressor repairs. The average lifespan of a central AC unit is 15 to 20 years, after which you buy another one and start the entire cycle again. A Badgir costs between $2,000 and $4,000 to construct once. It requires zero maintenance, zero energy, zero ongoing cost. It has a functional lifespan measured not in decades but in centuries. The towers standing in Yaz today were built before Christopher Columbus was born. You cannot sell a maintenance contract for wind. You cannot charge a monthly utility bill for physics. You cannot build a $240 billion annual industry around a tower that works forever for free. So what does a $240 billion industry do when a 2,000-year-old tower threatens its entire business model? It funds the curriculum. It dominates the building codes. It ensures that every architect, every engineer, every contractor who graduates from any accredited program in the Western world learns one system and only one system for cooling buildings. A system that requires their products, their refrigerants, their technicians, and their monthly energy bills. The International Building Code, the document that governs construction standards across the United States and much of the Western world, makes no provision for passive cooling towers as an acceptable primary cooling system. Not because they do not work, because they cannot be metered. Dubai built the world's first modern Badgir-inspired zero-energy cooling system in 2010. It works flawlessly in one of the hottest cities on Earth. The project won international architecture awards, and then quietly, it was never replicated at scale. The HVAC industry made sure of that. The knowledge was never lost. It was never disproven. It was simply made inconvenient for the people who profit from your dependence. Everything I am showing you today is just the surface layer of what was buried. I have spent months researching, verifying, and compiling every ancient cooling technique, every suppressed passive energy system, and every forgotten construction method that works better than what the modern industry sells you. All of it is inside the complete Ancient Prepper Survival Vault. The link is waiting in the description below. Ancient cooling systems, free water harvesting, off-grid food preservation, energy independence methods that cost almost nothing. Everything removed from your education in one place. Check it out and come straight back, because the next part of this video is the part that will actually change how you live. Here's exactly how to build a functioning Badgir-inspired passive cooling system for your home, starting today, using materials available at any hardware store or lumberyard. Before we get into the build, I need to be honest with you about something. A full traditional 4-story Badgir tower is a structural project that requires planning permission and professional construction in most Western countries. But the cooling principles behind it, wind capture, thermal mass, underground heat exchange, and natural convection, can all be applied at small scale to any existing home. And that is exactly what we are going to build. This is called a residential passive cooling stack. It applies every principle of the ancient Badgir at the scale of a standard home improvement project. Total materials cost between $80 and $150. No permits required, no structural modification to your home, installable in a single weekend. Here's what you need. First, 2 lengths of 10-inch diameter PVC duct pipe, each 4 feet long, available at any HVAC supply or hardware store, approximately $30 total. This forms your intake and exhaust channels. Second, 1 12-inch diameter underground cooling coil. This is 15 feet of flexible corrugated drainage pipe buried 18 inches below ground level in your garden. Below 18 inches, the ground temperature stays between 55 and 65 degrees Fahrenheit year-round regardless of surface temperature. Approximately $25. Third, 2 vent caps with directional louvers. One faces into your prevailing wind direction, one faces away. Approximately $15 each. Fourth, thermal mass material for your intake channel interior. This is simply concrete board or dense ceramic tile lining the inside of your intake duct. It absorbs heat from incoming air and releases it slowly at night when temperatures drop. Approximately $20. Total investment, $85 to $100. 1 weekend of work, 0 ongoing cost for the life of your home. Here is the assembly. Step 1. Identify your prevailing wind direction. Go outside at midday on a clear day and wet your finger. The cool side is where the wind comes from. This is where your intake vent cap goes. Step 2. Install your intake duct from the windward side of your roof or attic through the ceiling of your largest living space. The duct runs from outside down into the room. The interior of the duct is lined with your concrete board or ceramic tile for thermal mass. Step 3. Connect the base of your intake duct to the entrance of your underground cooling coil. The flexible drainage pipe runs underground at 18 inches depth in a gentle curve through your garden. At least 15 feet of underground run for maximum cooling effect. The longer the underground run, the more heat the air loses before reaching your living space. Step 4. The underground pipe exits the ground inside your home at floor level, ideally in your coolest interior room or central hallway. This is your cool air delivery point. The air entering here has already lost 15 to 20 degrees of heat passing through the underground coil. Step 5. Install your exhaust duct on the opposite side of your home, the leeward side, facing away from the prevailing wind. This duct runs from your ceiling upward and out through the roof or upper wall. The low pressure zone created by wind passing over the leeward side of your home actively pulls hot, stale air up and out through this exhaust channel. What you have now built is a complete passive airflow loop. Cool air enters from underground on the windward side. Hot air is pulled up and out on the leeward side. The system runs continuously as long as there is any wind at all. Even a gentle breeze of 5 miles per hour is sufficient to drive meaningful airflow through the system. On a day when outside air is 95 degrees, the air delivered into your living space through this system will measure between 68 and 75 degrees. No electricity, no refrigerant, no monthly bill. In 2022, a homesteader in Tucson, Arizona, installed a version of this system in her off-grid Adobe home. Tucson summers regularly hit 110 degrees. Before the installation, she ran a standard window AC unit 12 hours a day through the summer months, costing her approximately $220 per month in electricity. After installing a residential passive cooling stack using Badgir principles, underground cooling coil, wind intake, thermal mass duct lining, leeward exhaust, her interior temperatures during peak summer days averaged between 72 and 78 degrees, without any mechanical cooling at all. Her AC unit ran for less than 2 hours per day, even on the hottest days of the year. Her summer electricity bill dropped from $220 per month to $31. Her total materials cost for the installation, $112. She recovered her entire investment in less than 2 weeks of summer operation. The system has now been running for 3 years without a single repair, replacement, or maintenance visit. The Persians built Badgir towers across an empire that stretched from Egypt to India. They cooled palaces, homes, food storage facilities, and water reservoirs in some of the hottest inhabited places on Earth, and they did it so well that the towers they built are still cooling buildings today, 2,500 years later. The University of Reading confirmed it. Cardiff University replicated it. MIT calculated that it could eliminate air conditioning energy consumption for hundreds of millions of homes worldwide. And a $240 billion industry made sure it never appeared in a single building code, a single architecture curriculum, or a single mainstream conversation about the energy crisis. The wind outside your home right now is free. It has always been free. The geometry that turns it into 20 degrees of cooling costs less than $100 and lasts longer than any machine ever built. The ancient Persians figured this out before the Roman Empire existed. 2,500 years of proof, peer-reviewed science confirming every principle. And the only thing standing between you and free cooling forever is a building code written by the people who profit from your monthly electric bill. But today, sitting right here, you just learned what they spent millions making sure you would never know. Subscribe and share this with someone who needs to cut their energy bill. Every share keeps this knowledge alive. The next vault opens soon, and what is inside it has been buried even deeper than this.